Analytics show where an organization has been. Like a rear-view mirror, they provide a retrospective look based on historical data. Planning, by contrast, is about engineering future outcomes. It is a data-driven process where you use that past performance to make decisions about the future. In most organizations, these tasks are separate. This creates an architectural latency. By the time a retrospective report is analyzed, the window for prospective action has already begun to close. SAP Analytics Cloud bridges this gap by bringing analytic exploration and planning activities into the same environment. This diagram illustrates how the system houses both data streams in a single interface, allowing historical insights to inform plans directly. This unification allows an organization's past performance to drive future decisions without the friction of moving data between disparate tools. To understand how this works, we need to deconstruct the SAC architecture, from the foundational data models up to the automated allocation workflows. Planning becomes a data-driven, cyclical process embedded directly into the analytics engine. The planning process begins in stories. Stories are the visual containers for the tables, charts, and elements that enable you to modify your data. But that data must be supported by a structured source. Every story is powered by an underlying model. By enabling your models for planning, you turn on the features required to support complex planning activities. Your planning models require at least one time dimension to enable the analysis of the past and the planning of the future. This temporal access is mathematically necessary to project future states against your historical actuals. Models also contain multiple versions of your data to differentiate between your actual results and any plans, forecasts, or budgets you might need. This versioning isolates data into concurrent states. It ensures that a draft can be refined without altering the master records. Planners can work with public versions available to the whole organization, or private versions where only they can see the changes they are making. Within these stories, you can edit your plan using familiar table cells or work in Excel using the Microsoft Office add-in before publishing your changes to the rest of the team. Enforcing this structural control at the data layer prevents the chaos often found in free-form spreadsheets. Once the model is structured, the system must ensure data fidelity across a distributed organization. This security grid illustrates data access control. Administrators use this to allow users to read and write values only for specific dimension members. Validation rules add another layer of protection, allowing data entry only for specific predefined combinations of dimension members. Data locking settings further control when different segments of data can be modified within the overall cycle. These permissions and locks are synchronized with a chronological timeline. You manage this entire cycle through the integrated calendar, which provides a standard view of all tasks and dependencies. Here, you can set up planning events and track key tasks, such as data collection and entry, as they move toward completion. The calendar also serves as a collaboration hub, allowing team members to contribute to the plan while staying aligned with the master schedule. Governance provides the mechanism that ensures highly distributed, multi-departmental planning cycles remain synchronized and mathematically accurate. With a governed model in place, the architecture shifts from manual entry to automated execution. This flowchart represents the data actions framework. You can trigger these actions for steps in the planning process that need to happen on a regular basis. This includes copy steps that move values between timeframes and versions, and allocation steps that distribute values between dimension members based on specific business drivers. For more complex logic, advanced formulas can be built visually or through direct scripting. Multi-actions can chain these operations together, combining data actions with steps like importing external data via API calls. In addition to these workflows, the system can generate data automatically using mathematical models. SAC applies algorithms to historical time series charts to generate predictive forecasts. These forecasts can then be copied directly into your planning tables. This allows users to bypass manual calculation by ingesting algorithmically generated data into their plans. Data actions and predictive algorithms transform enterprise planning into an automated, programmatic exercise. The ultimate goal of this unified automated architecture is the ability to conduct dynamic scenario simulations. Value driver trees serve as the primary mechanism for these simulations. When you tweak a baseline variable, the system mathematically recalculates every intermediate dependency, allowing planners to explore scenarios and see the immediate impact on the bottom line. While users simulate these changes, data auditing optionally tracks every entry and modification made throughout the cycle. This auditing ensures transparency and accountability across every version of the plan. This entire architectural blueprint scales well beyond standard financial planning. It is applied cross-functionally to sales, supply chain, workforce, and integrated business planning. Implementing these capabilities successfully requires proven planning methodologies and architecture leadership, such as the framework-driven guidance provided by specialists like SACplans.com. SAP Analytics Cloud establishes a rigorously governed environment where historical analytics and automated predictive planning operate as one continuous enterprise engine.